Hi, everyone. I'll request all the attendees, delegates to please mute your microphone. Good morning, everyone, and good afternoon, good evening, depending on where you have joined from. Thanks very much for joining this session, Developer Best Practices in SQL Server. Before I jump over to the content, let me take the opportunity to thank the organizers for choosing my session and giving me this opportunity to talk about SQL Server best practices from a development perspective. This is SQL Saturday Los Angeles, June 2021. We are all virtual, and I know many of you might have joined from different countries and continents. And this is my first time speaking at SQL Sat LA, so really honored. Thanks, guys. My name is Amit Bansal. I have been working with SQL Server for a couple of years now. My core area of specialization is performance tuning. I happen to be a long-time MVP, also an MCM. That's pretty much about me. I'm just a SQL Server nerd. I'm on Twitter, _Bansal. That's the Twitter handle. All the learning resources, including the scripts, decks, not only from this event, but all other events, community events that I generally speak at, they're all available at sqlmaestros.com. So that's the unit I work for. So if you hop over to this URL, it's there in the chat window. You can jump over to free resources section and can download everything. There are a lot of other videos also. If you like my content and wish to stay connected with me, there's another URL where you can subscribe. Recently, I've been working on some a SQL magazine for the community, and it's up there. We have 2 editions, May and June. You can download that also. That URL is up there. So that's a very quick intro about myself. Let's talk about the content now. What are you going to learn in next 60 minutes? Developer best practices. When I work with customers, mid and large scale SQL deployments, time and again, I come across developers doing a lot of different things that are wrong when they are coding against SQL Server. Some of the things that I'm going to talk about today are very popularly known. In fact, when I kind of bring it up, some of you might think, oh, you already know this. Well, you know this, but there are so many others who are newly coming into SQL Server world every now and then, and they start programming against SQL Server database engine for the first time, and they make a lot of these silly mistakes that can cause performance issues. It's not really an issue with their coding, so to say, but it's just that how their code is going to be executed inside SQL Server engine, how it's going to be interpreted. Those are the things that developers probably do not know. And the intention here is to pass those important learnings. Now, there are many of them. And in 60 minutes, what can we cover? So I've picked up some common ones that I see across customers. And today I am going to talk about them. I totally appreciate that there would be some things that you would know, but I'm very hopeful that there will be a lot of new content that you will get to know. And I'm just hoping that you will learn something new today. So let's get started. What am I going to talk about? Well, I have 6 precise demos today to show you. Let's see how much we can cover up. The first one and the second one, I'm going to talk about non-sargability and when you have the right index yet seek is not happening. These are the first 2 demos that I'm going to talk about. Third will be a very common problem with SQL Server, specifically if you're not coding in the right way, which is about conversions, implicit conversions. And I have a couple of demos around that. Then I'm going to talk about SQL injection. I can bet you all of you know about SQL injection, but then again, I decided to bring this up as a topic because I see this again as a very common problem. And you would probably concur with me when I say that when we go to customers and we ask developers that, hey, have you heard about SQL injection? Do you know what it is? And do you know that you should be avoiding it? All of them say yes. And when you go and look into their code, they are making those mistakes again. So it's like theoretically they know, but just like practically, what are the things they need to take care of is not kind of well known. So I thought I'll bring this up again, like level 200 stuff at least. Then we're going to jump into slightly advanced stuff, dynamic SQL plan cache, parameterization, and even looking slightly towards query tuning, how your code can cause expensive bookmark lookups and analyzing the execution plans, etc. So that's what we have in the agenda. Let's get started with the first one. That is non-sargability. Non-sargability. So sargability means search argument ability, right? That is a kind of a made up term, not a formal English word, so to say. And in simple words, it means that when you have an index, the optimizer really wants to seek on that index. That will make the searching much faster than just scanning the index. But due to certain coding practices, the wrong ones, what happens is optimizer loses its capability to seek on the index, and then you land up scanning the index. Now, there are, in simple words, there are two ways how a non-clustered index can be utilized by the optimizer. Technically, we say this as access methods. Is either you go to the index object and scan it, which is go and touch every leaf level of the B tree structure. You know, index is a B tree structure with root, intermediate level, and the leaf level. Leaf level is the level where there is all the data, and it has pointers to the base table. Now you can scan, and of course, you know, scanning is not going to be very performant, so to say. And in most scenarios, you may want to seek. Seeking means you are traversing the B tree structure. You're jumping from root to intermediate to the leaf level. And non-sargability here, and I'm specifically talking about non-sargable predicates in this example, because non-sargability also can have different flavors and different variants. I'm giving you one such example, but then if you just Google around, you have so many community experts from SQL family who have blogged so much about non-sargability, and I'm sure you're going to get dozens of more examples. So now let's see this example in action. I'm using AdventureWorks 2016 for the purpose of demo. We are going to create an index called IDX SOD modified date. This index is going to be created on sales order detail table in sales schema, and the index column is modified date. I'm also including sales order ID. That's not very important, but let's do that. So the index gets created. Now, I have not even shown you the query, but I can just tell you in advance that I have created an index on modified date because I want to write a query where modified date is going to be in my predicate. And then when you say predicate, means I'm going to use this column in my search criteria in the where clause. And my expectation will be that optimizer is going to seek on that index. Now let's turn on actual execution plan. Let's do that. And for the sake of performance measurement, let's turn on these two statements, set statistics time and set statistics IO on. And you know what it does? Time will give us time information, time metrics, CPU time, elapsed time, and IO will give you some information about reads, etc. Now let's jump over to the query itself. This is the query in front of you. A very simple query. We are selecting a few columns from sales order header, and we are joining sales order detail. And see there, sales order header. This was the table. Sorry, this was the table sales order detail, SOD. And what are you doing? You are joining on the column. That's fine. Now comes the most critical part, where you say modified date is equal to something. Now, the moment you look at this where clause, I'm sure all of you are not feeling comfortable about something in this where clause, which is we are using a T-SQL function on the index column on the left hand side of the operator. The moment you do that, what happens is the index that we have on modified date, now this attribute is not going to be an attribute anymore. Instead, the moment you apply the function, the result of this is going to be an expression, and you're going to compare one expression equal to another expression, and the index is going to lose its seeking capability. That's where the problem is. Now let's go and run this and see for ourselves what's going on. So let's go and execute this. You don't get any data, which is fine. But if you jump over here, you can see that there is a index scan, non-clustered, and we can see sales order detail, and the index is being used, IDX SOD modified date. You can just make it out from here. But as you know, the problem is this one. We didn't expect a scan. We actually wanted a seek, but a seek is not happening. Let's jump over to the messages tab and look at some metrics here. So if you just scroll down a bit here, We can see CPU time is about 47 milliseconds and elapsed time is 388. That's fine. There is some CPU time that we have been has been spent. And on sales order detail, we had 337 logical reads. Now remember, this is a academic demo, right? Running on small data on a small table. So of course, all the numbers that you see here will be very, very small. But if you just take this example and think for a moment, if this query was running against the table with, let's say, 100 million rows or even a billion rows, imagine the amount of time this query would take. Imagine the amount of IO it would take. Now, let's record those numbers, and we know it's like 337 logical reads and 47 millisecond CPU time. Now, we didn't have seek and we expected seek. So let's go and fix this query, because this is the learning that we want, right? Like, we know, okay, we have an index, but we were not able to seek on the index. Index was still being utilized. Now I have rewritten the query. So when you rewrite the query and make the predicates sargable, when you make the predicates sargable, you want to ensure that the logic is functionally equivalent. And that's what we do here. We say now modify date greater than equal to something and less than equal to something. Well, you will have the scripts and you can peacefully spend time in comparing and evaluating. But the key point here, the key learning we have here is the left hand side of the operator is neat and clean. My attribute on which I have the index column is neat and clean. I'm not applying any T-SQL functions. There could be some exceptions, but most T-SQL functions, if you apply in your where clause predicate, that will be a non-sargable predicate. Let's go and run this and execute now. Let's jump over to the execution plan. The first thing you will notice, and you will be very happy about the fact that now we are seeking, we're not scanning, and this is what you wanted. First things. And of course, if you jump over to the messages tab, you can see that CPU time is just 0 millisecond, which means it was probably in microseconds, so negligible. And elapsed time has also reduced. So you can see something like, if you look at the scale of it, it's just not about every millisecond, but if you look at the scale of it, something that was like 47 units have come down to 0 units or even less than 1. That's the point. And the biggest benefit I would say here is logical reads. Look at logical reads. So probably you just read one page in the root page, one page at intermediate level, and another page at the leaf level. So IO comes down drastically. And of course, this is a no-brainer because scan versus seek will always give you that kind of magnitude of difference between IO and CPU. And this magnitude, as you know, and all of you can concur with me, will be much higher, the scalability factor, if this was running against a large table. One last thing about the no-brainer thing. What about if you compare both of them, and from the optimizer's perspective, you ask the optimizer which query performs better? Look at optimizer's estimation. So optimizer tells you very clearly that this is going to be 99% versus 1%. And that's just because of scan versus seek. The inference of this example, this demo, the conclusion here is not that seek is always better, always faster than scan, though in most cases that could be. But the idea is very simple. You have an index and you want the optimizer to seek on that index. Your index gets utilized. Sometimes when we are running diagnostic queries, we are trying to identify from a lot of these DMVs like index usage stats, index usage groups, etc. And we just kind of see whether the index is being used or not. Because if the index is not being used, you may want to get rid of it. But the other finer point here is index is being used, but is it being used in the right way? Is it being leveraged in the right way? That's the point. The continuation of this non-sargability, friends, is my next demo where I am talking about why seek is not happening. Now, this is another fun demo. I didn't mention in the beginning of the session. Feel free to ask questions at the end of the session. So you may just want to note down all the questions that you have, and I will have like 5-10 minutes to take up questions. I just want to complete all the demos first, and they're very simple and easy to learn and easy to understand. Now, the continuation. The first demo talked about you having the right index, but due to that bad predicate, the non-sargable predicate, seek was not happening. You fixed that and then seek started happening. Now here is an example where you have the predicates all well set. You have a sargable predicate. You're following the best practices of keeping the attribute neat and clean, everything, yet seek is not happening. Another common mistake that developers will do. Now, this is always very debatable. That is it developer focused? Is it something that DBAs should take care of? This is an age old debate between what comes under the purview of a developer, what comes under the purview of a DBA. We're not going to get into that discussion, but my simple assessment and conclusion here is, if you are working with SQL Server in any capacity, be it as a developer or DBA or architect, or just as a SQL practitioner, you got to know about these things, and it will really help in long term. Let's see what is this problem now. So we will again use AdventureWorks 2016, and let's go and turn on actual execution plan. There is a query here that we write, select star from person.person, very simple query where first name is equal to Ken. Now let's go and run this query. I've not created any index right now, but I'm assuming that there might be some index on first name, last name, middle name, so on and so forth. When I execute this, I get the data. Thankfully, I get the data this time. In the previous demo, there was no result set. Anyway, you jump over to the execution plan, and what you see here is, again, there is an index called ix person something there, but then there is no seeking happening. It is again an index scan. Now this time I'm not even showing you the index definition. What index is this and how is it created? What's the schema of this index? Which are the columns? You don't know anything. But all you know is that there is an index, but it is being scanned. Now the other thing that we note here is that SQL Server is recommending you to create an index. So there is a missing index hint here. So if I right click on this and just go over to missing index details, it tells me to create an index on first name. Now this is interesting. It tells me to create an index on first name, but if I go over to the execution plan, there is an index which the optimizer is using. And if I take the cursor over this and just kind of go and look at the object name. The zoom is slightly misbehaving. So let's try this once more. Okay, and go here. I just want to jump over to the object. Okay, looks like it's not working, but anyway, I won't zoom. So if you look at the object there, just below predicate, okay, let's do this. You can see the object name which says ix person, last name, first name, middle name. Now let's make some assumptions here. The assumption that I'm making here is that there is an index on this table called person, and maybe following some naming convention, looks like the index has 3 columns: last name, first name, and middle name. And probably the order of columns here is last name, first name, and middle name, which means this index did exist. Optimizer has used this index but was not able to seek on this index, and then optimizer recommends you to just create an index on first name because first name is the only column in your predicate. Now all of you know about missing index hints, right? They are not the best things in SQL Server world. They have a very bad reputation though. But I want to give some concession to missing index hints and probably tell you that they're not so bad as they are ought to be, because they are good hints. You just got to look at the hint here and see if it is making sense, because in case it's not making sense, you can always ignore them. But sometimes the hints do make sense. This time when it is giving me the missing index hint and tells me to create an index on first name, it starts ringing some bell that I already have an index which has last name, middle name, first name, etc. Last name, first name, middle name, and then it tells me just to create an index on first name. What I do is let me just go ahead and rewrite the query once just for the purpose of testing and put both the columns first name and last name. Why am I doing this? Because when I look at the existing index and the order of columns, last name is the first column in the index definition, first name is the second column, and middle name is the third column. I am sure many of you know that the order of columns in your index definition does matter. It matters a lot. But the order of columns in your select statement does not matter. So if I have first name is equal to Ken and last name equal to Sanchez, if I just reverse it, really doesn't matter. But the order of columns in your index definition matters a lot. Let's go and run this for a moment. Now I have taken first name and last name, but I did not take middle name because middle name is the third column. So I'm just ignoring it for the sake of simplicity. And I'm taking the first two columns in my index definition and I've put them in the predicate. And if we go and execute this and jump over to the execution plan, wow, you are seeking now. This is the most interesting thing. In both the queries, when you had first name and then the other one where you had first name and last name, in both of them, the predicates were Sarg-able. No T-SQL functions, no non-equality operators, nothing like that. Very straightforward, very simple queries. But yet in the first one, seek was not happening. But the moment you include last name, it starts seeking. So what's the difference between the first query and the second query? The differentiating factor is this attribute last name, which happens to be the first column, the first field in your index definition. So here is the rule of the optimizer. And this is another common pattern that we see with customers, and developers DBAs will in most cases sometimes keep wondering why I'm not getting the best performance out, why despite having the right index there's no seek happening. The rule of the optimizer is that if you are seeking on second column, you got to seek on the first column. If you're seeking on the third column, you got to seek on the first and second column, because the index searching, traversing happens from left to right. It's like a left-based subset mechanism, starting from left all the way to right. So first column, second column, third column, which means in your query, if you skip the first column and try to seek directly on the second column, that's technically not possible the way how index data is organized. And that is the missing piece in this one. So I hope this rule of the optimizer is clear here. Left-based subset mechanism, you're searching, you're traversing from left to right. So if you want to seek on subsequent columns, ensure that in your query, you're even seeking on the previous column, starting from first all the way from left to right. Now, I know what all of you might be thinking. You might be thinking, hey, Amit, are you telling us that I need this query, but you're just kind of forcing to include even last name? No, I'm not doing that. I'm just telling you what the optimizer would do and what you want to do. So either you just go ahead and create this index first name, follow the hint and probably create the index, job done. But if you create an index on first name, something like this, you know that this index could be slightly redundant because you already have an index with first name. So why not try to do certain things where one index can satisfy multiple queries? You don't want to land up creating one index for each query. You might have 1,000 different ways on how you are selecting or retrieving data from a table. That would not mean that you land up creating 1,000 different indexes. So either you do that, create the index, which may not be a good idea, or you modify the query if that makes sense. And maybe you can, in your application, you may ignore the last name column or something, or you could probably just modify the existing index and swap the columns, where if this is what you really want, why not? If then this is the querying pattern, and if you're not really seeking on last name, swap the columns in your index definition, where you can put first name as the first column and last name as the second column. A lot of different options exist. You just got to evaluate what kind of querying pattern do you get. So I hope with the first two example, kind of focused a lot on indexes, but really having the right indexes does improve performance a lot. But in these examples, I showed you that you do have the right index, but they were not being used by the optimizer in the right way. The first example talked about Sarg-ability. The second example, everything was fixed, everything is right, yet seeking was not happening. Hope these demos were useful. Let's move on to the third one now. Well, third one is talking about implicit conversion. Again, a topic, very overloaded topic, and we all speak a lot about this, and I'm sure some of you kind of know this really by heart, what you should try to avoid in implicit conversion. I am not just going to discuss and show you a very basic demo, though I will start with that just to ensure that all of us are on the same page. But then I'll go one step further and even show you that sometimes instead of implicit conversion, you might probably think about explicit conversion to kind of improve performance. So let's go and see how this works. We're going to use AdventureWorks 2016 again, set statistics time on because I'm going to measure CPU time. And here is a very simple query. We are going to read some data from person.person, that's fine. Look at the predicate. We say where account number is equal to some value. Now this literal, this string that we give here has a prefix n. So I'm telling SQL Server that this is Unicode data. However, if I take the cursor over account number and just kind of zoom in a bit here, you can see account number is defined as varchar. So what we are trying to do is compare varchar with nvarchar. So nvarchar here, because of this n prefix, because of kind of trying to follow a practice that the app always works with Unicode data, we kind of prefix with n. But then we don't realize that with this query now, there is going to be a varchar to nvarchar implicit conversion. You are not asking SQL Server to convert, but SQL Server will have to convert to perform this comparison. Let's turn on actual execution plan and execute this. So the decision of conversion, you're leaving it to SQL Server to decide. SQL Server will of course spend some time in evaluating from which data type to which data type precedence, higher, lower. Of course, a lot of these permutations are going to be done. Let's go and execute and jump over to the execution plan. And I'm not going to get into the details of execution plan, but just one focused attention on the select operator here. And you can see that there is an exclamation mark warning, and that's a good thing. At least the optimizer, the execution plan here tells you that there might be something wrong with the execution plan. So let's take the cursor over here and go and look into the warnings. And again, my Zoom thing is misbehaving. So let's just keep it to here and hopefully you can see warnings there says type conversion in expression, convert implicit something, something, right? Which means SQL Server is warning you that it's performing implicit conversion because of which there could be some bad things. Anyway, let's jump over to the messages tab here and scroll down and you can see that CPU time is 157 milliseconds, which means SQL Server has taken those many so-called CPU cycles to do this execution. And I'm not trying to say that this is completely attributed to the conversion, but then this is the number. Keep this number in mind, 157 milliseconds. Now, there is implicit conversion. Let's go and fix it. Well, the first fix is relatively very straightforward and very easy. I'm just removing n here, right? So just go and remove n here. Oops, sorry, like this, and it is done. So both are same now. And you can just do this. Now I have varchar on both sides of the equality operator, right? The attribute is varchar and the string is also varchar. If we execute this now and go into the execution plan, first thing, no warning, select statement does not show any warning. Let's jump over to the messages tab now and scroll down and wow, this is very interesting, 0 milliseconds. So the CPU cycles here for this, I would request the delegates to please mute your microphone. Much appreciated. Thank you. So when you look at this one now, CPU time, it says 0 milliseconds. So you've brought down like 157 milliseconds all the way to less than a millisecond. So that's why it says 0 ms. Now, when we see something like this, you might be thinking, wow, do we really bother about every millisecond here? It's when we look at performance, look at SQL performance, query performance in totality. It's not just about this singleton execution. It's just not about one user executing this query just once during a single business day hours. Queries like these, workloads like these, hit OLTP environments in thousands, in tens of thousands throughout business hours. I'm talking about a kind of a heavy loaded OLTP app and line of business application running against SQL Server, typical chatty workload. Thousands of these come on every minute basis, and so many users, hundreds of users are executing it. If you take all of that into account and multiply this, you will see the huge amount of CPU cycles that you can save. And this is what I do day in, day out, tuning SQL Server with our health check, is find such tuning opportunities which will overall bring down CPU consumption, overall bring down memory consumption, overall do better IO usage, etc. So but the point here just not is that I'm trying to show you 157 to 0 milliseconds. You can in my next example, I'm going to simulate multiple users hitting SQL Server, and we will see that in action. But before we do that, let me show you one more thing. What about explicit conversion performance? And this is where I told you I'll want to go one step forward, because I just assume, I make a lot of assumptions that probably you might just know this. But what I see with some customers and developers, that they don't know about explicit conversion, which is why leave the decision to SQL Server? If you really have to convert, tell SQL Server that, you know what, I have this account number, I'm using the convert function, and this is the string. Please convert it to varchar. This might turn out to be better probably. So let's just go and test this. So if I select this, go and execute, you get the output, and let's jump over to the execution plan. Of course, no warning because explicit conversion was done. And let's go over to the messages tab, scroll down, and wow, you again have 0 milliseconds, which is good. So explicit conversion does a better job here. Now let's talk about the scalability factor, right? So here, and if you're trying this demo on your machines also, feel free to go and do that. I have created a script here called 3.1 conversion.sql, and we're using AdventureWorks 2016, and it's the same query, the bad one, implicit conversion with the n prefix. So this query is going to be called by this command file, 4_50 users.cmd. Let's just open it and see what it contains. I'm going to increase the font size just for you to kind of see this properly, and probably do a word wrap. Okay. What are we doing? I'm using Rml Utilities. It's a tool created by the SQL team, which has set of tools. It has one executable called ostress.exe, and idea is very simple. Using this executable, I am going to stress SQL Server with 50 users, and they are going to execute this script file, which has this bad query with implicit conversion. 50 users are going to hit, and they are going to run in 30 iterations. That's what we are going to do now. Let's see how this works. So I'm going to run this. It's running, and implicit conversion is happening. 50 users are running that SQL file with implicit conversions, 30 iterations. And now what are we trying to test here? We are trying to test scalability factor, because sometimes to customers and clients, a few milliseconds of performance improvement is not convincing, right? They want to see the magnitude and scale of it. And that's why I create these academic prototypes to kind of show that, yes, how things might turn out to be bad. All right, this one is probably taking a bit more time than I was expecting. 50 users iterating 30 times. Okay, done. So this has taken, friends, 47 seconds. That's the total execution now, right? And let's go and fix this query now, which was this one, right? So we're going to fix it. We are going to turn this off, right? That's what we're going to do, and we're going to save this, which means no more implicit conversion. And as a homework, let's say after the session and after the event is over, if you have energy and if you have time, why not do this yourself? And instead of this, put the query with explicit conversion. Might be that will be a good recap and something that you can do on your own. And let's do this stress testing again. Wow, was it so fast? Not really. Okay, so let's open this once again. Did we do the right thing? Wow, that ran in a jiffy. Okay, so here is the query. Okay, and did you see just what happened? And I'm calling this one again. Look at the execution now. It is less than a second. Can you just believe that? This is the performance that we are getting. So if a few milliseconds were not convincing, this definitely should be very convincing. And we again ran 50 users iterating 30 times. So look at this, that 47 seconds just comes down to 1 second. That's the scale we are talking about. And of course, you can always multiply it with some more real world numbers. All right, friends. So this brings us to the end of the third demo, which is about conversions, about implicit conversions. Okay, so the next three demos are SQL injection, dynamic SQL, plan cache, and query tuning. But looks like I have about 24 minutes to be precise. If chat is working for you, may I know from you, what do you want me to show you now next? SQL injection, dynamic SQL, plan cache, parameterization stuff, or bookmark lookup and query tuning? 4, 5, or 6. This is in front of you. So if you can just use the chat window, let's just do a quick survey, because I looks like I will not be able to complete all the three demos, but I can just pick up two demos from here. Which one would you like to see? 4, 5, or 6? At least that will bring me to some conclusion. Are you really? Oh, wow. All of you are paying attention. That's so nice. Okay, so we are. Okay. 4, 5, 6, 4, 5, 5. Injection,
Looks
injection.
like you're predominantly in the 4 and the 6.
4 and the 6, right?
Yeah.
Okay.
I mean, there's 5s in there too, but.
Yeah. Okay. Tough question. I shouldn't be asking such questions, actually. That was fun. Okay, so friends, let's.
And you can go over by a couple minutes too. That's fine. We have a 15-minute
Oh, really?
pad clean.
Okay, perfect. That really helps, Brodie. Thanks for letting me know that. So, friends, let's do this. Okay, I hope you're really enjoying the content. Let's jump over to 4, and I will try to do all 3 of them. I'll just move a little faster, and hope you will be able to keep up with this. So let's get started without any delays. And just for people who just came a bit late, maybe, or I'm just putting down in case you want to download all the scripts, etc. So I've just put all the links in the chat window again. So there you go. Let's get started with SQL injection. Now, this demo is, of course, a very basic demo of SQL injection. And my intention here is to just bring it on top of your head that do not ignore SQL injection. Focus on parameterization, because developers continue to write queries without explicit parameterization. And that exposes their code to hackers and to inject SQL code via their let's say stored procs or whatever. And here are some examples. So just calling things out. Let's use AdventureWorks 2016 again. This database has been very useful for us today. What we're going to do is drop all these objects, and I think these objects are already dropped. They're not there, so I can skip over that, and let's jump over here. We're going to create a schema called dummy authorize DBO. That's fine, and this is a stored procedure. The stored procedure name is USP get product details. It takes one parameter, which is prod name, the product name, and then we want to get a few information about that product based on the product name that is supplied. Very simple stored proc. Let's go ahead and create it. Done. And now we are going to execute the stored procedure. So we say execute dummy.getProductDetails, and the product name is, let's say, shorts. And when we execute this, you get all these products which have like shorts in their name with color, size, list price. Everything is fine. Simple stuff. Now, what am I trying to do? And I've put notes here just to ensure that I don't miss out anything. I'm going to pass a variable like this below. And after passing the input parameter, there is some special code that adds an OR condition. 1 is equal to 1 will always be true in that condition. So we are going to get all the details from the table, but we will get an empty result set. And I'm going to explain you why, because there is probably no scope for SQL injection when writing static SQL. So this stored procedure has static code in it. Now let's see what we are doing. Dummy. So let's assume all of us are kind of trying to hack inside SQL Server via SQL injection. So instead of executing the stored proc with just the name of the product here, we say shorts or 1 equal to 1, and then I comment out the rest of the stuff there. So this is going to execute. Let's go and execute this. We don't get anything. Now, the one interesting thing here is, of course, this doesn't work, but it doesn't even give you the data, and it just gives you an empty result set. Why? Because you have a static code inside the stored procedure, and the formation of that, why you get an empty result set, is because this is how it is internally treated. So when you pass this entire thing as string here as part of the variable value, it comes as where name like shorts and this entire thing. And actually, there's no product where the name is like shorts or 1 equals to 1 something. So it just gives you an empty result set. But look at the fun. Um, I know what you're thinking. So here is what happens when you are using Dynamic SQL. Now we all know Dynamic SQL is used heavily inside SQL Server, and some developers just love Dynamic SQL. It is a very, very powerful mechanism for application coding, but it does come with some pitfalls, and this is one of them, SQL injection. We have altered the stored procedure now, and instead of putting static code, I am putting my select statement inside a variable, and I'm using the exec statement to execute the code that is in the variable. Dynamic SQL execution, simple. So let's go and alter the proc here, and of course you can evaluate these code pieces later. Let's go down. Now what we are trying to do? We are trying to do the same thing now. Instead of getting the products with shorts, we have got all the records, which means now Dynamic SQL is going to behave very differently, and you will see absolute SQL injection in action right now. Same thing. This is the same execution, friends, where product name is equal to shorts or 1 is equal to 1 hyphen hyphen, which is comment out the rest of the code. Let's go and execute this. What do you get? You get all the products. Look at this. Not just shorts, but you are getting everything from the table. This is SQL injection in action. And this can actually turn out to be worse. So, but before we get into more worse results out of this, what is happening inside SQL because of this Dynamic SQL is building the code inside SQL this way, which is get all these columns from product where name is like shorts. We say either the name is like shorts or 1 is equal to 1, and then comment out the rest of the stuff. So or 1 equals to 1, 1 equals to 1 will always be true, and you have an or condition, which means either the product is short or just give me everything. And when you execute this, which is what internally happens in the stored procedure, you get all the data. Pretty bad. Now, if this wasn't bad, look at this. This way, the hacker, the individual is trying to inject, can actually see all the databases on the server. Union-based injection, and of course, some guesswork is needed, but it still can be done. Which is, I'm calling this product name is equal to shorts, and then I say union all select name 111 from databases. So I'm giving some default values out there, and then again I'm commenting out the rest of the code with 2 hyphens there. Inline commenting. Let's go and execute this. Do you see this? From your stored procedure, which was supposed to give the name of the product where product name is like shorts. Instead, you get the name of all the databases. And now these are all the databases in my SQL instance. So pretty bad. And here comes a very interesting part. This code will give me an error, but I can still get the server name. Now, what we are trying to do is execute the stored procedure, again pass the parameter, and this time I say and 1 is equal to @ server name. So let's go and execute this. This is going to give us an error, conversion failed, because there is no conversion, but I get the name of the server. You don't want to expose the name of the server to any unauthorized user, right? So that's the name of the instance, actually, SQL Maestros, and sorry, name of the server, and that shows up in the error there. Look at the worst part. I mean, look at the wild imagination and how bad it could be. This just one mistake. You can actually create a database now. So what are we doing now? I'm executing this shorts and then we pass on this statement. This is very, very funny, very, very interesting, very dangerous also. Create database SQL Maestros underscore SQL LI, SQL injection. Will this work? But before I run this, let me show you that no such database exists here. So you can see there's no database called SQL Maestros underscore SQL CLI. I have SQL Maestros, but not underscore SQL LI. So let's execute this, and it runs actually. And if you refresh this, you can see that there is a database here called SQL LI. It can just go as bad as this. And likewise, friends, you can even drop the database, and you can drop with remove all connections and whatnot. Uh, this is probably even worse than creating the database. Now, if I refresh this via SQL injection, you have just dropped the database. That database is gone. So what do we do? And okay, a lot of these examples, there could be just more. SQL injection is a huge topic. What do you do? First thing, do not throw database errors to the client application. Catch the database errors inside your SQL code and give more user-friendly errors to the client application. That's one of the best practices. The second is perform input validations, which is if someone is really trying to inject something like these, all these wildcard characters and whatnot, I mean, cut the code out there itself, just kind of say raise error, possible SQL injection attempt, etc. But I will tell you the strongest thing, the best thing to do is explicit parameterization. Explicit parameterization will not only help you in avoiding SQL injection, but my next demo is about plan cache and parameterization. It's going to help there as well when you have many of these queries with variety of parameters coming in. It can create parameterized version of the execution plan and can help in avoiding plan cache bloating scenarios. So this is really good. So let's try to just quickly do all of this. First, I'm altering the store procedure. And if I say someone is putting down product name as all these wildcard characters, I'm just saying possible SQL injection attempt using the raise error function. And I'm not going to execute the rest of the code. That is what we do. So let's go and execute this. And let's try to do a SQL injection now. And what do we get? If we do this, and we get an error, thrown back to the client, possible SQL injection attempt, code terminated, whatever. Good one. Let's do explicit parameterization. And I'm a big fan of this. Here, I will not spend too much time in explaining you how this is being done. You have the code to yourself. So please review this. But the idea is very simple. Instead of just concatenating the SQL string with the variable or the parameter value inside the stored proc, I will create a param definition variable and I will add a parameter called product name of nvarchar50 to the definition and then declare my string. And then I'm going to use dynamic SQL, sp execute SQL to execute the string and then also supply my parameter definition and give value to each parameter. For example, for my parameter prod underscore name, look at this prod underscore name, the value is coming from this variable, which is add prod name. So if I have multiple parameters, I can just put comma, put them equals to where is it coming from, comma, the next one, so on and so forth. That's the kind of syntax we follow here with parameterization. This concept of parameterization, explicit stuff is kind of common in the database world. We do the same in Oracle world also. We do the same in SQL. It's just syntactically things get a little different, but the concept is same. Let's do explicit parameterization. Now, look at this stored procedure. There is no check here now of wildcards, special characters, or anything like that. Just explicit parameterization, very neat and clean stuff. And let's try to do the injection again. Product name, adjustable race, we put the product name, or 1 is equal to 1. Again, we're trying to inject. Let's go and execute. Nothing, doesn't work. Simple. So explicit parameterization is really good. Well, with this, let's do this cleanup. And this was really a very level 100 demo of SQL injection. And if you are someone who's new to SQL, you just got started programming against SQL Server, please be aware of this bad thing, very bad thing, SQL injection. All right, I have 10 minutes. I think I will do a good job today to complete all the demos. Let's jump over to dynamic plan caching. And this has really to do with parameterizing your queries, very similar to what I showed earlier. So I can go over this one very quickly. The idea is very simple. All of you who are probably new to SQL Server as a DBA or as a developer, there is one thing inside SQL Server which all of us should know. When you send your query to SQL Server will create an execution plan to execute your query. And that execution plan remains in something called as a plan cache, which is an area of memory. And you can see hundreds and thousands of plans in that plan cache. And why does your execution plan remain in the plan cache even after your query execution is done? Simply because the process of creating an execution plan, the compilation, the optimization is kind of CPU intensive process. SQL Server does not want to do that every time your query comes in. And it's happy to just kind of store the plan in the plan cache so that if your query comes in a second time, it can just reuse the plan. That's a wonderful mechanism to improve the so the overall performance. However, your query can have parameters. That's where things get really weird. When you have parameters, let's say select star from person table where name is equal to Amit or name is equal to Brodie or name is equal to John. Look at the query. The query signature is same. Select start from person where name is equal to. So the signature is different, just that the parameter values are changing, right? Brodie, Amit, John, Michael, so on and so forth. Now, how does SQL Server treat that internally? Well, if you have not parameterized your queries correctly, SQL Server may create one plan for each parameter that is coming via your query, which means if you're actually executing your query with 100 different names, you may have 100 different execution plans in the plan cache. And that may be really bad. And this is, you want to really avoid this because you might have 100 different parameters or 1,000 different parameters that will just, what we call in SQL Server world is plan cache bloat, which is you have all these single ad hoc execution plans, single use plans lying in the plan cache, not being utilized again, not being used again. And this may have very bad impact on the overall plan cache, overall memory consumption, etc. So let's see how this works. Now I will first take this query. Okay, so there are a lot of helper queries here, friends, and this one is not really very well organized, but I'll just try to get the concept to you. Look at this query here. When you look at this query here, you have the select statement, and where you're trying to fetch a few columns from human resources.employee, where manager ID is equal to what? Equal to value of 1 to manager ID 1, 2, 3, 4, so on and so forth. And you're running this select statement in a while loop, and you're replacing the manager ID with this variable count, which means I'm going to run this 100 times for 100 different managers, where manager ID is going to begin from 1, go all the way to 100. That's what we are going to do. Before I run this, I'm going to free the proc cache, which is clearing the plan cache using this statement. Never run this on production. I mean, without knowing the consequences of this. This is going to just kick out all the plans from the plan cache. I'll request the delegates to please mute your microphone. Thanks. And we have this query which is going to and this is a DMV, a bunch of DMVs that we are using, query execute stats. And I told you about the query hash, right? Query signature. I'm trying to see if there are similar query signatures right now where the occurrences are more than one, which means are there duplicates? That's what I'm trying to do. If I execute this right now, Let's do this. You can see there is no query in my plan cache right now. There's no plan in the plan cache right now, which has kind of duplicates, right? Where what I mean by duplicates is similar query, but with different parameter values, nothing at all. But now when I run this one, right, the one that I showed you with 100 different parameters, let's free the proc cache, run this once for each manager, 100 manager IDs. Is it still running? Yes, it's running. You can look at the toolbar there. Just may take a few seconds. And yes, we are done. Now this is done. And if we just straight away jump over here, you can see now there are 100 such entries in the plan cache. And this is a sample query, select employee ID, national ID number. This is the one that we ran, right? And what this query is giving me right now, this diagnostic query is giving me that this particular statement, select statement query has 100 duplicates, which means they all have the same signature, just that their parameter values are different. This is plan cache bloating, and you want to really avoid it. With my helper queries here, friends, I could show you a lot more internals, but maybe some other day because of just time brevity right now. I'm not trying to show you the size of the plan cache, number of plans in the plan cache, looking at some of the clerks. I mean, of course, this topic is really, really huge and very interesting too. But let me just straight away come to the point. And the point is parameterize your queries. Very similar to what we discussed earlier. Here is the fix. Just look at the fix for a moment while I drink a glass of water. Look at the query, and it is just parameterizing. Okay, my throat was drying, so just had water. I feel much better now. Let's continue. And isn't this very similar to what we did earlier? Creating a parameter definition and adding a parameter to the definition, which is manager ID. And the value for manager ID comes from our local variable CNT. And we are looping again, and dynamic execution happens in the same way. You can see parameterization is an awesome thing. And despite this best practice being so popular, we still see people not doing much of parameterization. So let's do this now. So we're going to free the proc cache and execute the same thing. We're going to do the same thing, but with parameterization, and it will take a few seconds. Running and running and running, but now you have only one parameterized version of the query. So let's go back up and run this one. And this should just give me nothing at all. That's it. We have no query in the plan cache, which has duplicates. So let's put count, let's say just greater than 0, for example, and it will just give me everything. Number of entries are all 1. That's where it is. And look at your query now, and you may find something different than what you saw earlier. Earlier, you just saw select employee ID, national ID number, but this time you also see @manager ID tiny int. That is what we call as parameterization. Your query, this execution plan is parameterized, and the parameter is clearly called out in there. And then any incoming query is actually just a shell query with different parameter values, but they use the same plan which is there. And in simple words, this is the parameterized plan. It has only one entry, not 100 entries, and very well optimized for the plan cache. And it really helps SQL Server in many, many ways. Friends, again, this is a huge topic, but I just tried to compress it to send you the key message: parameterize. That's the point. All right, let's close this and move on to the final demo. And I'm happy that I'm able to complete all of them. Wow, query tuning. This one, bookmark lookup. This is really DBA stuff, trying to analyze execution plans and see where is the performance improvement and all of that stuff. But this has to have a developer focus too, and that's why I covered it here. But so let's go and look at the demo, see what the problem is, and then we'll try to understand the DBA part and the developer part. And I'm going to give more focus to developers. So let's use AdventureWorks 2016 now. Thank you, AdventureWorks 2016. You have been very helpful in all the demos. Here there is a simple query here. So thanks to Adam Mechanic, I'm using his script to create this huge table, two tables, DBO big product and DBO transactions. DBO transactions has millions of rows and DBO product has a few thousand rows, which has all the product information. So what I'm trying to do here is get, so I'm doing a cross apply the outer query and I'm doing a cross apply with this inner query. So this inner query, which is getting me top 1000 records from DBO transactions, this inner query is going to run for every product from the outer query. That's what cross apply is. This inner expression is going to run for every record from the outer query. And I just put a clause there where product ID is between 1000 and 7500, just a filter there. We're going to insert this data into a temporary table called hash X. Let's turn on actual execution plan and run this. And we are going to record how much time this query takes. So let's go and execute this. Now, I'm not telling you what I'm trying to do, but let's keep this in mind. Let's just first watch the demo step by step as to what's going on. So 3.2 million rows were affected. They were inserted into a temporary table called hash X, and it took 4 seconds. I'm not zooming in, but if you can just look at the bottom right status bar, it took 4 seconds for this. So if you go to the execution plan, 4 seconds, it's a parallel plan, a lot of parallel operators. Everything looks good. No problem. I know I'm overshooting time. I'll just take a few more minutes. And now everything looks good. But then let's change the scenario a bit. For some reporting application, for some other requirement, there was a need to add customer ID column to the transactions table. This is not your requirement. I'm just trying to create a scenario, right? A simulation. Someone wanted to add customer ID to the transactions table. So we altered the table and add customer ID column. So a new column gets added. But remember, data has not changed. Your query has not changed. And we are going to drop the table, free the proc cache, free the clean buffers, just to make sure that the second run is tested. Now I'm going to run this query again. And let's turn on actual execution plan and execute this now again. This time you have customer ID column. That's the only change in the table. Your query is same and the data is same, but look at the execution time now. It's much more than what it was earlier. This is totally to do with query performance tuning, query tuning, and it has both a DBA focus as well as a developer focus, and hopefully you will love the demo. Now this is taking more than 30 seconds, is it? Yes. Okay. Took about 30 seconds, 28 seconds to be precise. 4 seconds to 28 seconds. Something is going terribly wrong. Jumping over to the execution plan, there may be a lot of different things to look at, but just let's try to focus on one operator here. I know your attention will go to the sort operator because there is an exclamation mark warning on the sort operator here, but don't look at the sort right now. I can talk about that sometime later as to why all sort is looking bad, but the focus is key lookup. Look at the cost factor of key lookup, 80%. And why is that happening? Because if you take the cursor over key lookup here, and if you look at the number of executions, again, if I zoom in, maybe it may not work properly. Yes, it doesn't. So please help yourself by looking at the number of executions, 3.9 million times. This is looping key lookup. And what object is it looking for? What output column ID? So that's customer ID. So if you look at output list below object, it's looking for customer ID. So from the index, it does a lookup on the base table to fetch customer ID. Customer ID was this attribute that you added just very recently. Now, the overall story here is that SQL Server is recommending you a missing index information. It's telling you to create an index on product ID and include all these columns in your included keyword. Remember, SQL Server will always recommend you these covering indexes. But as a matter of fact, what is going wrong is you already have an index which has product ID, transaction date, quantity, and actual cost, but it does not have customer ID. That is the problem. So previously, when customer ID wasn't there, your existing index was very useful It was able to cover the query, and you were getting all the data from the index, and the query was running in 4 seconds. All good. The moment you add customer ID column, things go bad. The current existing index is not useful, and it has to do a lookup from the existing index to the base table to fetch customer ID. So what do? Do you add a new index, or do you go and modify existing index? You can modify an existing index and add customer ID column there, job done, and the query is going to run faster. But all of you, surprise for all of you, that is not the solution. There's no problem with the indexes here. If you thought indexing, I'm again showing you a demo with indexes and seeking and scanning and covering or searching or navigating or column orders. No, this demo is not about indexes. So let's switch this off. This is all about the developer, and the best practice, do not use star. That is the problem. Do not use star. I want to rewrite the query like this. Look at this for a moment. Instead of star, if my query actually had actual cost, product ID, quantity, transaction date, because your query only wanted these columns: actual cost, product ID, quantity, transaction data, and transaction ID. It didn't want customer ID. Remember the scenario: customer ID is a requirement for some other app. Remember this, we keep talking about this change mechanism, right? Like a change request. But this keeps happening in production all the time, right? New columns being added, existing ones being dropped, and all the mess. So if your query, if you were following this best practice of not putting star and actually specifying the columns that you wanted, that addition of customer ID would not have impacted your query. So here is the answer. I'm not doing anything. I'm not going to add any column. I'm not going to add any index. I'm not going to modify any index. Let's test the query again the right way, which is I'm going to do this without the star. And this is going to run in again 4 or 5 seconds. And this is what you wanted. There you go, 3 seconds and job done. So you see a very real world classic example of, we keep talking about in theory that do not use select star, but this is very practical how select star can be so bad. This is one learning for the developer: select star. One of the most basic best practices that we learn in the so-called very first T-SQL lesson, so to say. But the other thing is, the second most important learning is, do not test your queries with small data. Because if the same query, the one that was taking like 30 seconds or 40 seconds, if that query was running against a table with just a few thousand rows, it would have run really fast, and we would not see the problem in our dev or test environment. But when you take that query, put it into actual production server with millions and billions of rows, the query would perform so poor. So test your queries with some real data, at least with huge data, kind of representative of your production workload. I have seen developers testing their queries with empty tables. Yes, you hear me right, empty tables. So with empty tables, queries are really going to run very fast. Well, friends, with this, I come to an end of all the demos. And yeah, these are some of the links. I'm on Twitter, _Bansal. Please feel free to give some feedback on Twitter. And yeah, I'm just putting up the links again. And if you wish to stay connected, go to sqlmaestros.com to download the scripts and everything. And the membership is all free. Friends, no credit card, nothing at all. Don't worry. Just download. And there's a lot of videos also, a lot of free learning out there, etc. So hope all of you have enjoyed. Happy to take questions, if any. This was the first session, and hope it sets a good pace, worth your time. So yeah, thank you so much, all of you. Thanks, SQL Saturday Los Angeles. Yeah.
Thank you very much. This was phenomenal. We did have one question from Courtney, and that is, what about running procedures under accounts with minimum necessary permissions? If you aren't running as SA, you can't create or drop the database, can you?
Yeah, very good question. I think that makes sense, but I am not really a security expert as to how the execution context works here. But I think the statement made by the person is actually correct, because if I just have execute permissions, that impersonation will not happen. So I may not be able to create or drop. But as a reality, reality is that we don't want to leave such things to chances. I have seen all sorts of mismanagement, even when it comes to users, permissions, security context. So it's better to be safe than to be sorry.
Absolutely agreed. And I mean, I don't know. It's certainly been true at the firms that I've been at, where a lot of times you install a new piece of software and it needs to have DBO in order to do something. So that always comes up quite a bit.
Indeed. I've also put down the YouTube channel link where I have put a lot of performance stuff, short tutorials. It's there in the chat window. SQL Maestros. That's where everywhere. YouTube.com/SQL Maestros. So friends, please feel free to subscribe.
Thank you very much, Amit.